Hi, and today I want to talk about CPM, CPAN client. Yeah. First, let me introduce myself. My name is Shoichi Kaji, and my post ID is Kaji, and I am the author of course, CPM and MI6, PerlCon authoring tool. Okay. So before beginning, I want you to ask a question. Have you ever used CPM? Thank you. Thank you. Thank you. Okay. So this is an agenda, and first I will talk about 5 features of CPM, and second, the internal of CPM, and third, I'm going to talk about towards CPM version 1.0. So yeah, CPM is a CPAN client, and it has several features, and I want to introduce you 5 features here. So first, it is fast. Yeah. And this is why I created CPM. Yeah. So let's compare CPM with CPAN-M. So first, CPAN-M. CPAN-M, dash notice, dash quiet, and local lib, and Insole plug. I think you are familiar with CPAN, aren't you? Yeah, it took some time, and it took 30 seconds. Remember, 30 seconds. Okay, next, CPM, and CPM Insole plug, and dash bubbles, and time. Yeah. Okay. CPM Insole plug took 10 seconds. Yeah. Okay. So CPM is 3 times faster than CPAN. Yeah. I think this is amazing, isn't it? Okay. And second feature is CPM is self-contained. Of course, you can install CPM via CPAN, but also you can use dependency-free self-contained CPM, which works fine with FreshPerl 5.8.1. Yeah. So you can download CPM this one-liner by this one-liner. Okay. And it also it is easy to use CPM in CI, such as Travis CI. So you can use this one-liner to install dependencies. Yeah. Third feature is CPM has flexible resolvers. You can change CPM's resolvers via resolver option. Right. So let's say you have DACPAN, which contains your private distributions, but not whole CPAN distributions. Yeah. In fact, other CPAN clients, such as CPAN minus, do not work well for such case. Yeah. But CPM does. So if your DACPAN does not contain whole CPAN distributions, and first resolve your DACPAN and fall back to normal MetaDB resolver. Yeah. The fourth feature is static Insole. Have you heard static Insole? No. Okay. Leon has proposed a new concept for CPAN distribution installation called static Insole. Maybe 5 years ago. It is much simpler, safer, and faster than traditional run. Here, traditional run means executing makefile.pl. And CPM supports static Insole. I wrote a blog post about static Insole, so you can refer to it. Okay. The fifth feature is it supports pre-build. Yeah. Okay. CPM keeps builds in home par dash CPM and never fetch builds them again. This is inspired by Carmel. Carmel is a product of MIYAGAWA. This makes CPM even faster. So let's see example. So first, again, install plug. And first installation took some time. And yeah. And install remove local and install again. Yeah, it's only copy build to certain directory, so it is so fast. So if you change other directory, yeah, it's just copy, so it's so fast. Yeah. Okay. So these are 5 features of CPM. And first, it is self-contained. It has flexible resolvers, and it supports static Insole, and it supports pre-build. Yeah. Okay. So the next topic is let's see the internal of CPM. Yeah. Why CPM fast? Yeah. Okay. If you want to make program fast, I think there are some programming paradigms. Yeah. First choice is multi-thread. And second choice is event-driven. And third choice is multi-process. So which paradigms do we adopt? So first, let's consider multi-thread. Yeah. But yeah, as you know, it is not a good idea to use thread in PerlCon. Yeah. So do not. So.
Can you tell why?
It is a long story. So let's forget about multi-thread in part 5. Yeah. Yeah. So the next choice is event-driven. Yeah, I think this is a good choice. But here, once we adapt event loop, we cannot use synchronous code anymore. So CPM actually uses CPAN minus in internal. So if we adapt event-driven, this means we cannot rely on CPAN minus code. Yeah. So I don't adapt this choice. So let's use multiprocess. This is traditional one, but let's see. Okay. So let's use multiprocess paradigm. Okay. Then next questions are, how do we pass data from the master to workers and vice versa? So yeah, how to communicate each other. So yeah, the next question is, the master needs to know that workers finish their jobs as soon as possible. How do we achieve this? So let's consider question 1. Yeah. How do we pass data between processes? Yeah. It's called IPC, interprocess communication. And there are several choices. First choice is to use files. Yeah. So, but other process does not detect files are changed quickly. Yeah. So it appears, and you can use iNotify, but it appears iNotify is slow for CPM. Yeah. So I don't adapt files. So the next choice is TCP/IP, and I think this is a good choice. But here, because in CPM, master process and worker process are in the same host, so we don't have to use TCP/IP necessarily. So the third choice is pipes. So let's use pipes. Okay, and yeah, we need to communicate each other from master process to worker and from worker to master. Yeah. So, but sorry. As you know, pipes can use bi-direction, but it is good practice to use single direction. Yeah. So let's prepare 2 pipes for master to worker and worker to master. 2 pipes. Not use 1 pipe. Prepare 2 pipes. Yeah. And okay. So question 1 is use pipes. So the next question. The question is the master. How does master detect which workers are finished? Yeah. And quickly. Yeah. Sorry. Oh, okay. So go. Okay. worker will send result to the master via pipe, which also means the worker are finished. So yeah, master process send jobs to worker, and worker process jobs and return result. Yeah. So so if the master monitor pipes by select system calls, it can detect which workers are finished quickly. Yeah, okay. So wrap up so far. So we adopt multi-process paradigm and connect master with worker via 2 pipes per worker. Yeah. 2 pipes. And master monitors pipes by select so that it detects which workers are finished quickly. Yeah, select monitor. Yeah. So this is the actual code of CPM. So yeah. So I modularized connection between the master and workers as parallel pipes module. So this creates this fork process and create pipes. Yeah. And master gets job. And with its ready method of parallel pipes, get ready workers here. And internally, we do select pipes here. Yeah. And get ready worker and send job to the ready worker. Yeah. This only 11 line code makes CPM faster. Yeah. This is the critical part of CPM. Yeah. Okay. So the third topic is toward CPM version 1.0. Yeah. I actually wanted to release CPM 1.0 before PerlCon 2019. Yeah. But I didn't make it. So I want to talk about the plan. Yeah. In CPM version 1.0, I want to make distributions first-class object. So yeah. Traditionally, we install CPAN modules into one specific directory. Yeah. So after install, we cannot see which distribution a module come from. So let's say I see plug request.pm file. Which distribution does this belong to? But we cannot answer the question. Yeah. And if we install one specific directory, and it is hard to reuse distributions. Yeah. So I don't think this is a good idea. So, and on the other hand, MIYAGAWA has introduced a concept, central repositories, in his project Carmel. And here he manage distribution instead of modules. Yeah. So I think this is the same direction. So let's keep each distribution separately. Yeah. This is what I want to do in CPM 1.0. So yeah. So once CPM implemented it, for example, CPM can easily install only runtime dependencies. Yeah. It run tests during installation, but only install runtime dependencies in the end. Yeah. I think this is okay. So sorry. So this is last slide. Sorry, wrap up. So CPM is a fast CPAN client. Yeah. But it also has some other interesting features. Self-contained. It has flexible resolvers and static install, and it supports previews. Yeah. And CPM uses system calls fork pipe select effectively so that it installs CPAN modules fast. Yeah. And CPM 1.0 will treat distributions as fast-first objects. So, okay. Finally, I want to thank the organizers and sponsors of PerlCon 2019. And I attended PerlCon Summit. So I want to thank organizers and sponsors of PTS. And of course, thank you to coming this talk. Okay, that's all. Thank you. Sorry. So.
The default number of workers is hard-coded to 5. What is so special about 5?
My favorite. If we bigger than 5, I don't think it's much faster. So okay. Yeah. 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 Thank you.
So, is there a way to specify defaults? Because I find I always, whenever I use CPM, I find it installs locally by default, right? And then I always want to go back and add define global or something. Is there a way to specify defaults already?
No.
Okay.
Yeah.
Repeat the question.
Okay.
My question was if there's a way to have defaults for the options to see.
So the answer is no.
Do you have a time? You have the microphone, and the microphone doesn't know the question. Sorry, I don't. Yeah.
So my suggestion
Do you want some configuration file?
No, I just want to what I would in my options what I would do is I would turn on global so that it always installs into the main tree, and I would probably turn on tests as well. And I always forget to do that whenever I use it. I go back to it again.
Okay. Okay. So I wrote a blog post. So let's see the blog post. Okay. So yeah. So yeah. Okay. Yeah. Traditionally, CPAN modules are normally distributed with makefile.pl, and this makes CPAN module installable without any CPAN client help. Yeah. This is a good thing in the past. But nowadays, people mostly use CPAN clients, such as CPAN.pm, CPAN-m, and CPAN Plus to install CPAN modules. And it seems that when CPAN modules are not complicated, CPAN clients easily expect how to build, test, install them, even without executing makefile.pl. Yeah. So now, yeah, static install means if CPAN modules are not complicated and set x static install 1 in their meta.json, then CPAN client use their own builder to install that distribution. Yeah. Do not execute makefile.pl. Yeah. Yeah. Okay. So I think this is a good idea, and I want you all adapt static install. Yeah. So why do you make your CPAN module static installable? Yeah. I think we have 3 merits. First, it is fast. Yeah. And more importantly, it is safe. There is no place to execute arbitrary code during installation. So we execute Perl makefile.pl to install CPAN modules. So it means module author do anything. Yeah. I think this is not safe. So yeah. Okay. This is the explanation of static install. Oh, sorry.
When you say the CPAN client uses its own installer, does that mean, what does it do? Does it just copy files and run the tests, or does it do more than that? In the case of a static install, is it just copying the files, or what is it doing internally?
It reads dependencies from meta.json, and it copy lib and binary files to blib directory, and in the last copy blib directory to certain directory. Yeah. Any other questions? Okay.
Thank you.
Thank you very much.